Hello guys, in this video I'm going to show you how to solve employee free time problem. So for K employees, we are given a list of intervals representing the working hours of each employee. Our goal is to find out if there is a free interval that is common to all employees. You can assume that each list of employee working hours is sorted on the start time, right? Okay, let's take a look at a example. So we're given a list, right? And this list contains sublists, right? Each sublist will represent working hours of one employee. So here we have two employees, right? And as you can see, the first employee will be busy in this in this these two intervals, right? 1, 3, 9, 12. On this side, employee E2 will be busy at 2, 4, and 6, 8, right? So our goal is to find the free interval that is common to all employees, right? So let's uh, take a look at this diagram. Uh, it will be very clear, right? So the square braces will be of employee 1, and the curly braces will be of employee 2, right? 1 and 3, as you can see, 1 and 3, and 9 to 12. On this side, 2 and 4. Here's from 2 and 4 and 6 and 8, right? So you can see it will be very clear that from 1 to 4, we can't find any free time from 1 to 4, right? Because from 1 to 2, it is busy time of employee 1. From 2 to 3, both employee 1 and 2 are busy. 3 and 4, employee 2 is busy. But from 4 to 6, we have a common free space here, right? So 4 to 6 will be included in the free times in the output. 4 to 6 here. Another common free time is 9 to 8. Sorry, 8 to 9, right? Right. So how wanna solve this problem? Uh, a very intuitive idea here is that we can start looping from every interval, right? Starting with the one with uh, smallest n time, right? This one, and to this one, this one, and this one. So at each interval, we're gonna check the current start time, and probably we need to compare with the previous end time, right? So for example, initially we'll start with this one, right? And there's no previous end time, so we just skip the first one. But for this one, here's the second interval. We compare with the first interval, and as you can see, using the we can compare start time and end time here, and it's clear that these two overlap, right? So there's no interval, there's or common end time. Sorry, common free time. Uh, there's no common free time, at least until the end of second interval, which is 4. So we start at 4. It means from 1 to 4 there will no free time. So we move to the next interval, which is 6 to 8, right? And as you can see, the previous end time is 4 and current start time is 6. So it means there is a free space here between these two intervals, right? So we can store the order 6 to the output here. Oh, sorry. Okay. So after 6 interval, we move to the last one, 9 to 12. And as you can see, we compare start time of current, which is 9, with end time of previous, which is this one, at 8. And it greater than 8, right? So 9 greater than 8. So there is a common free time here. From 8 to 9, right? So we store 8 and 9 and move to the next, but there's no next interval. So we stop here and we've done with finding the common free time, right? And let's get into coding. As we discussed, we have to loop. We have to kind of have a list of all intervals flat, right? Sorted by start time. But as you can see here, our input is not flat, right? But it contains sublets, and its sublets further contain intervals, right? So we first need uh, to flat it out so that we can loop to every you can loop intervals easily. For example, this you end up with 1 3 2 4. Next one is 6 8. So probably we need two steps here. First is to flat it out and then sort it in start time. But here I try to combine into one step. So after two operations, we end up with this sorted flat array, right? 6 8. 6, 8, and 9 and 12. All right. Uh, so for the to flat the input out, right? Then I need to sort the flat array by be careful here. Each list of employee working hours is sorted on the start time. What it means is that each subarray is sorted by itself, but when we flat it out, it will be no longer sorted. So we need to sort it again. Sort the flat by start time. Okay. And next step is to loop, iterate. Let's say iterate every interval, compare current start time with previous end time, right? Okay, firstly, working hours contain sublist, right? Contains subarray. So let's say I'm gonna first uh, accept each subarray of working hours. All right. So with each subarray, I'm gonna use another loop to accept to each interval subarray here, and the final flat version will be flat is an array, and uh, for each interval, I'm gonna push in the flat, right? So after this nested loop, we're gonna have a flat array storing all interval, right? But then I need to sort it flat. I need to sort, uh, taking a callback A and B. Uh, A and B is actually interval, and because I want to sort it in uh, sort it by start time in ascending order, so it will be A minus B start time. So I will accept 0 index, right? 0 index will be start time, index 1 will be end time. All right. So iterate every interval, compare current start time, previous end time. Okay. So let's say uh, because for the first interval we don't have the previous end time, so we can instead we can start from the second one, right? So we are sure that for the first interval there will be uh, previous end time to compare. So let's first store the previous end time to uh, flat. First, the first item in the flat will be the first interval, then end time will be index 1, end time of first interval. uh, okay, I'm gonna start to loop from I equal to 1 and I run all the way to the last index, right? So I less than flat dot length less than flat, okay, I plus plus. All right. uh, so current interval will be, no, we can, what we need here is a current start time. So it will be, the current is flat at index I, start time will be 0. Okay, what are the cases here? So let's draw it out. Here's a previous interval. The current interval could be, the start time could be uh, inside this range. It in this way they overlap, right? Another case, here's the previous, but the current current interval here, it uh, is inside the previous end time, previous interval, right? Another case is that it, another case they don't overlap, right? So if it is this case, it means we will have a free time between these two intervals. So we have case 1, we have case 2, and case 3. Okay, so let's check this one first, because here is what we need. Probably I need a free time arrays that will be storing the common free time. So at the end I will return free times. Alright, so if it is a third case, it is when the current start time is greater than our previous end time. So if it is a case, I will push in the free time, but the free time interval here is actually from the previous end time to current start time. Previous end time to current start time. Alright, so if this is not the case, then we're gonna run into either one of these cases, right? It is when they overlap, right? So for when the current interval overlap with previous interval, it means we don't have free time between these two intervals. So what we need to do here is what do we need to do here? We don't have free time, so probably we let's say, so we need to reassign the previous end time, right? So currently the previous end time, for example in this case, previous end time is here, right? Let's take a look at this guy first. Previous end time is here, right? And here's a current start time. So if we run into this case, right? Uh, I need to reassign previous end time, right? So that before moving to the next interval, let's say, right? Let's say before moving to this interval, right? The previous end time must be this instead, right? So actually here, uh, what I need to do here is that uh, previous end time, I need to reassign it to uh, current end time, right? I need current end time here. Uh, so because I need current end time, so here I, instead of getting index 0 here, I will destructure it instead. From this current interval, I will destructure it into current start time and current end time. So previous end time will be what? Will be current end time. But is it true with this case? Let's say we are here, current interval. So let's say before jumping into the next interval, let's say this one, I need to reassign the previous end time. If with this one, the previous end time will be equal to current end time, which is here. Uh, so if I move to this interval, my previous end time will be here. But actually, uh, what I want here is what I want to be the previous end time here should be the one that ends uh, later, right? So here should be the previous end time instead, right? So here is not what I want, but the previous end time should be the whatever that is larger between uh, previous end time and uh, current end time, right? Or if it is its case, I also need to reassign previous end time. If this is a case, then we are pretty sure that uh, previous end time will be uh, previous end time will be current end time, right? Sorry, here is the we are here. Uh, so let's say before moving to the next interval, I want to reassign to here instead. Right? So in this case, the previous end time that is currently here, it should be reassigned to here, current end time. But actually, these two can be simplified as so we can remove the L cases block because in both cases we want to reassign pivot center, right? And this statement will cover also this one, right? It will still be true, right? All right. So I think that is it. Let's run the test. Okay, it works. So that is it for this problem. Um, but actually, this is still not the optimized way to solve it because there's one piece of information that we have not used, we have not taken advantage, uh, which is all the sublets here are sorted by itself, by themselves. Right? Here we don't use it because here we fat it out and we try to sort it again. So how uh, how much time? I mean, in terms of bigger notations, this implementation will be running in. You can see here we flat it out. So actually, uh, we need to visit all the intervals inside this. Let's say, for example, we have n intervals in total. Uh, this will run in O of n. We sort this one. It will be n log n, right? And here we again we use one for loop to loop to all the to loop to iterate through n intervals. So it will be n. So in total, this implementation will cost us n log n, right? Which is still not the best. But since this video is been nearly 30 minutes, so I'll be explaining another way, a faster, a faster way to solve this problem. So this video, it is it, and thanks for watching. See you in the next one.